viewers and fellow researchers. Welcome to Brain Redefined. On this hot sunny day, we bring to you a sizzling hot research paper. We, the speakers from Team YOLO, are going to walk you through our revolutionary findings. I am Rohit Rajesh, and you'll be meeting Gautham in a while. This research paper is loaded with information that shall change the future. But this presentation is not going to be an unexpected boring one, but a really fun and informative session. Welcome aboard.
The future of memory is an exciting one, filled with various possibilities, including ways to upload and download human memory, artificially creating memories, and most importantly, curing brain diseases such as dementia and Alzheimer's, which have plagued humanity for centuries.
Past research has shown that our physical and emotional growth is directly linked to our environment. What we see, what we hear, what we feel, all these are central to our future decisions and the predictions made by our minds. The dendrites of our neurons, they grow larger, they grow bushier with each word that we hear, each word that is said to us, each experience that is stored in our memory. Now, our brain and hence our actions are a large network of neural signals that are created by our brains. And each of these signals that affect our actions are influenced a lot. The creation of the signals are influenced by our memory, by the experiences that we have had in our past. But you can't expect things to stay the same. People with dementia and Alzheimer's, when they go out, they forget the way, they get lost. And in the most extreme case, people mix up memories. So they remember events that never happened. Faint memories of different parts get mixed up and they start imagining stuff. And this leads to a very serious issue. Each of their future actions are decided by this false memory that they have created, and this affects a lot of people.
As most of us know, memory deteriorates with age to the point of dementia. This has caused an enormous amount of pain and suffering, not only to the patient, but to the family and friends as well. The brain is essential for the functioning of the entire human body, and to lose all the experiences and memories that it contains is a sad consequence of old age. All the research and studies that have been conducted thus far have been unable to truly cure these diseases. That is, until today.
Now, coming to our objectives, our primary focus would be to solve memory problems associated with dementia and Alzheimer's. Secondarily, we would also focus on connecting the brain directly with prosthetic arms and stimulating more precise actions by amplifying neural signals. While researching in this field, we came to understand how the brain signals are generated and how these signals control muscular response. And then that led to the secondary objective, where you can directly link the brain with prosthetic arms instead of the prosthetic arms being connected to the spine. And thus our thoughts can result in direct movement of arms and actions.
The first attempts to translate neuronal activity into commands to control external devices were first made in the monkeys in the 1960s. This experiment helped in vastly expanding our understanding of how brains of evolved animals worked. Brains of humans and monkeys are remarkably similar in the way they function and how they are organized. So this helped us understand more than ever of how our brains functioned. With Elon Musk's Neuralink, micrometer precision robots are used by neurosurgeons to embed chips in people's minds so that they can read and influence neurological signals.
Coming to the significant researches that have been conducted in this field, number one is an experimental study of Oriental medicine. This research was conducted in South Korea on aged rats. Aged rats are known for their proper learning paradigm of behavior. So in the demonstration, they performed radial nerve medicines and Oriental medicines to aged rats. And the results suggested that Oriental medicines can effectively cure short-term memory deficits that are age-related. And regarding long-term, unfortunately, their results were inconclusive and further research was required. The second one is a brain-computer interface in neurological rehabilitation. So BCI technologies might more effectively restore motor control to people after stroke or other traumatic incidents. So once people age and after a traumatic incident, the brain becomes more plastic. The amplitude of brain signals decrease and the time taken response time increases. And in the worst case, some traumatic incidents result in abnormal activities. So all this can be reduced using BCI technology. BCI technology can be used to read and understand the brain signals and thus assess the brain's current activity state. And thus it can also be used to supplement muscular control and muscular response. Also, through BCI technologies, research has achieved controlling applications, mobile applications by just thinking. So thoughts can be directly linked to your mobile, which can control other electronic devices and thus bypassing the impaired neuromuscular system. The third major paper in this field is the role of axonal transport in Alzheimer's disease. So Richard Wilson in his paper has told that the key to improved understanding of the brain is a process vital to brain cells called axonal transport. So an early event in the progression of Alzheimer's is the disruption of axonal transport system. And this is linked to the lesion formation and brain dysfunction, and hence he says that a full investigation of this process would lead to a cure, or if not, at least a prevention.
With Neuralink, brain chips enabled monkeys to play the game Pong. Aged rats were successfully able to complete mazes that they performed in their youths. However, rats that did not have any brain chips implanted in their brains were disoriented and did not know how to navigate through the maze. We also noticed that the short-term memory of chimpanzees were extended by about 1 minute. This does not sound like a lot, but considering the fact that the short-term memory of chimpanzees is only about 1 minute, this is a huge increase in their memory span. Tests on humans showed promising prosthetic limb movement that performed almost identically to organic limbs.
So these are the results of our experiments. We believe that the onset of age-related memory loss can be delayed by at least 10 years. Through the integration of BCIs and axonal cell improvement, there is hope to cure dementia and Alzheimer's. We also believe that we could dramatically improve long-term memory and people can remember with great clarity events that happened decades ago. Even people without Alzheimer's or dementia suffer some amount of memory loss, and all this can be cured. We believe that brain signals can bypass impairments. These brain signals created by the BCI technology can effectively improve muscle response and control prosthetic arms through muscles. So signals generated can be amplified and result in contraction and expansion of muscles, making people who are differently abled who use prosthetic arms feel that they are doing something on their own.
More rigorous experiments on humans need to be conducted in order to cure other neurological diseases such as brain palsy, brain tumors, and aneurysms.
In our future works, we would also like to understand the brain at a deeper level and try to explain the different patterns and implications that we have to date only observed. Additionally, we plan to dig deeper and take the BCI tech to a level where extra limbs and appendages can be added to the human body and convert everyone's childhood dream of being a superhero into a reality.
As you can see, these are the references that we have used.
To conclude, brain chips would be the future of human intelligence. Memory loss would end in extinction, and thought shall control computers as the new era. Thank you.